So good afternoon, everyone. Thanks for joining us today for DataBytes with the National Consortium for Data Science. My name is Amanda Miller, and I'm the Associate Director of NCDS. Today, we are delighted for Chris Lamb to present AI ethics through the lens of causality, a theory of fairness. And before we begin, I'm going to share just a few housekeeping items. You may notice this event is set up as a Zoom webinar and not a meeting, which allows us to focus on Chris's work and not one another. We have disabled Zoom Q&A for attendees. Chat is also disabled to allow Chris to present without distractions. But never fear, we do offer a place for you to share your comments and questions. All questions and comments should be uploaded to our Easy Retro, which is our crowdsourcing Q&A platform. My colleague Jay Shree will share the link to that platform in the Zoom chat now. And we'll share instructions and the link for this once again before we begin the Q&A portion of our session. If we don't get to your question or comment during this webinar, please know that we will address it in our wrap-up materials. And without further delay, it is my pleasure to welcome Chris Lamb.
Thanks, Amanda. So my name is Chris Lamb, and I'm the CEO and founder of a new AI startup called Epistamai, which is based off the word epistemology, the theory of knowledge. Let me see if I can share my screen, and then we can begin our presentation. Can you guys see my screen?
Yes. Looks great.
Okay, sounds good. So my startup is focused on understanding the role of causality to try to solve difficult problems within the AI ethics space. And one area which we've been particularly focused on is the role of causality in solving problems related to fairness. So let's start with a question. Why should data scientists study causality? Because I think this is going to be the trend of the future. Machine learning relies on correlation. But as we've all heard, correlation does not equal causation. So for example, as ice cream consumption goes up, drowning deaths also have a tendency to go up, and there's a spurious correlation between these two variables. We can explain why this spurious correlation exists through a confounding variable. For example, temperature. As temperature goes up, it causes both an increase in ice cream consumption and an increase in drowning deaths as more people swim. So to build a fair model, we need to understand why protected attributes like race or gender causally affect other variables. But it's not as simple as just replacing, say, temperature with a confounding variable like race or gender, because it can lead to a very difficult and complex discussion. So let's talk about perhaps taking a more first principles approach to fairness compared to other approaches that we've seen in the fairness and machine learning community. So building a fair model means returning back to first principles. We may have heard that fairness is a socio-technical problem. And what we need to do is we need to bridge knowledge from the social sciences and humanities to mathematics and computer science. So let's start with the first part of looking at fairness from a social sciences and humanities perspective. So let's begin with the premise that humans have free will. We know this is a highly controversial subject of whether humans really do have free will, but we're going to make the assumption that humans do have free will. And in philosophy, free will is the idea that we humans can make our own decisions and have control over our own outcomes. And this is what makes us different from machines, which are programmed by humans and have no control over their own outcomes. But with free will comes the need for moral responsibility. Since humans have free will, we can be held morally responsible for the outcomes of our own decisions. Since machines have no free will, at least at this point, they cannot be held morally responsible for the outcomes of their own decisions. Now, the decisions that humans make can impact ourselves and others. And most of the time, we humans make decisions that only impact our own selves. And we can think of this as agency. And we humans are personally responsible for such decisions. But sometimes humans make important decisions that impact others. This is especially true for humans who are in positions of great power. And we can think of this as structure, and humans are socially responsible for such decisions. Now, decision makers are responsible for both good and bad outcomes. So when a decision leads to a good outcome for other humans, one might be assigned credit, and humans have a tendency to accept credit. But on the other hand, when a decision leads to a bad outcome for other humans, one might be assigned blame, and humans have a tendency to want to deflect blame. And these ideas form the basis of accountability, as society needs to hold humans responsible for the outcomes of their own decisions. Now, we update our premise that humans are not fully free. There's this idea in sociology called structure and agency. And the idea is that in sociology, structure plays a major role in limiting one's agency. That is, we're not free to do anything we want to do because society does not allow us to do whatever we want to do. It would not be acceptable, certain types of things that we might be interested in doing. And our outcomes in the world are caused by both the decisions we make for ourselves, agency, and the decisions that other people make for us, structure. And I repeat, our outcomes in the world, according to this theory, is that it's both a function of the decisions we make for ourselves, our agency, as well as the decisions that other people make for us, the social structures. Now, I want to issue a warning that we're about to go down a very dangerous causal rabbit hole. And the following slides may cause cognitive dissonance, which is a state where there could be inconsistent beliefs that could cause mental stress. So this is a trigger warning. And I want to offer you guys an option. If you take the blue pill, you leave the presentation right now and go back to believing whatever you want to believe. If you decide to take the red pill, you stay in causal wonderland, and I will show you how deep this rabbit hole goes. So I'd like to take a pause and give you guys the option to leave the presentation and take the blue pill right now, if you so choose. I'm going to assume that everybody in the presentation has decided to take the red pill. Remember that this was out of your own free will. I never forced you guys to take the red pill. Now let's ask the central question of fairness, one of the central questions. Perhaps this is the trolley problem of the fairness problem, which is, why do disparities exist between groups of people? This is a highly controversial question that presents us with a causality dilemma. There is a fundamental disagreement on the root causes of these disparities. As I said before, our outcomes in the world are determined by both structure and agency. And trying to assign blame solely to one cause or the other creates a false dichotomy or an either-or fallacy. But it's still very important to look at how each side would view these issues, even if doing so generates bias. If people believe that structure is a primary cause of creating disparities across groups of people, then people might be more inclined to believe this is a social responsibility problem, that social structures are responsible for causing disparities across groups, and any disparities caused were beyond the group's control. This is more on the less privileged groups. So less privileged groups, the reason why they're less privileged, they're more disadvantaged, the disparities were beyond the group's control. People, on the other hand, who believe that agency is a primary contributor to the disparities across groups of people might see this more as a personal responsibility issue, that individuals are responsible for causing disparities across the groups, and that any disparities caused were within the group's control. That is, that less privileged groups were actually able to close the disparities within the own group as opposed to being beyond the group's control. People who are more biased towards structure as the explanation for disparities might see inequality as a bug of the system, reflecting structural discrimination, historical injustices, and the systemic denial of resources from the groups most in need. People who are more biased towards the agency side might see inequality as a feature of the system, motivating individuals to make better choices through the unequal incentives provided by the invisible hand of capitalism. People who are more biased on the structural side might believe more in the idea of group fairness. That is, that different groups, regardless of differences in average qualifications, should receive similar outcomes. Whereas those that are more biased on the agency side would be more focused on individual fairness. That is, that similar individuals, regardless of group membership, should receive similar treatment. People on the who are more biased towards the structural side might be firm believers in John Rawls' theory of justice, which states that all individuals begin from an original position of equality. That is, before you're even born, the idea is before you even know who your parents are, what your socioeconomic status is, what your race or gender is, we all started from a position of equality. We were all equal to each other. And therefore, the principles of justice are to be chosen behind this concept called a veil of ignorance. That is, there's a veil that separates us from our original position where we're started off as being equal to where we are today, where we have our own positions, our own biases. And the idea is to create this veil of ignorance to start from this original position of equality. On the other hand, folks on the agency side might be stronger believers in Ayn Rand's views of objectivism. That is, that reality is objective, it is what it is, and not what we want it to be. That is, it is also independent of one's consciousness. So her view is to accept reality as it is, that we're not all starting from this position of equality, that yes, there are differences between all of our positions, but that we should then learn how to deal with it rather than trying to imagine that we can go back to before we were even born, where we were all equal to each other. On the structural side, one major thinker when it comes to differences in race is Derek Bell and his theory of critical race theory, which argues that structure is a contributor to disparities in outcomes across race, and this generates bias within the data, and that interventions are needed to achieve social justice. On the agency side, people might be following Tom Sowell. So for example, he wrote a book on discrimination and disparities in which he argues that interventions can cause harm to groups, generating perverse incentives among individuals that explain disparities in the outcomes across race. So one is more focused on the structure and how it generates biases and why you need interventions. The other is Tom Sowell, on the other hand, is arguing that you shouldn't be making interventions because they can cause unintended consequences for the groups that you're trying to help, and that you should just leave the data alone. And then finally, people who are more focused on structure might tend to be more likely to line up with left-wing and more progressive politics, which believes more in strong government intervention in order to correct for social injustices. And people on the agency side might be more on the right-wing side of the political spectrum, so more libertarian, and believe in the idea that limited government intervention is needed to protect individual freedoms. So now we can see the divide between the politics and structure and agency. And we can think of fairness as kind of like the spinning two-sided coin. That is, fairness is constantly in two states at the same time, the left state of structure or right state of agency. And for this theory, we treat these two states as being symmetrical. And that's important to maintain this theory as one that's nonpartisan. And we can see after every democratic election cycle which state the coin lands on. So that's the social side of this theory of fairness. Let's now move on to the technical side and discuss the connection between causality and machine learning. So now let's take a look at this part of the problem, the math and computer science. So to build a fair algorithm, we need transparency. So here's a representation of a machine learning model where you have some data, you're feeding it into this machine learning black box. It could be like a neural net or a gradient boosting machine or logistic regression. And out comes some type of decision, for example, to approve a loan or to screen out a resume. And then there's this big question about what about this protected attribute? Should it be used? Should it not be used? If it's used, how do you use it? And there's a lot of discussions around the fairness and discrimination around whether or not we need to open up the black box and to figure out if it's discriminatory. But one of the key to opening up the black box was never to open it up at all. What if instead we could take this whole problem, this machine learning representation, and turn it into a causal Bayesian network? And if you do that, then what you might get is something that looks like this. So here we have a causal Bayesian network with 5 nodes. Data is represented by X. It is then fed into a black box, which is inside this node Y hat, which renders some type of decision. And in this case, the protected attribute, which is represented by A, is not used in the decision, although we'll show that there are different ways of modeling how to use the protected attribute to modify the decision. But the idea here is that by modeling what is happening outside of the black box, we have enough information to identify whether a model is fair. So let's talk a little bit about how I built this graph and what do all of these nodes represent. We begin with a graph that has 3 nodes, the protected attribute A, which could represent race or gender, for example, the mediator W, and the outcome Y. And we can use this graph to model fairness across 3 domains, but it could also be modeled across more domains than just these 3. So let's take a look at credit decisions, okay, where the mediator W represents credit worthiness, and the outcome Y that you might be trying to predict is, for example, would a person default on a loan? You can also use this to model hiring decisions, where the mediator W represents your employment qualifications, and maybe you might be predicting whether or not an employee is going to churn. You can also use this to model college admissions, where the mediator W represents intellectual merit, and perhaps you're trying to model to predict whether or not a person will drop out of college or drop out of a particular program. So we say that the protected attribute A causes mediator W, which in turn causes the outcome Y. And what happens is that the mediator W explains away the relationship between the protected attribute A and the outcome Y. That is, if we had perfect information about W, then we wouldn't need any information about A to predict Y. This property is known as conditional independence. The problem is that we can never have perfect information about W since it is latent, which is why we represent this using a white node compared to the black nodes for A and Y. But we can still partially measure the latent mediator W to get data X. So we instead have this node here, X, which is a partial representation of the mediator W, which is used to generate the decision Y hat over here. And Y hat is represented by this equation where we have the one function, which is basically checking to see if the probability of an outcome given the data is less than some threshold T. Okay. So in credit decisions, examples of data X that measure credit worthiness might include your income or your credit history, which is used to render a decision Y hat, such as approve a loan. In hiring decisions, the data X would represent your work experience or your education, which could be used to render a decision Y hat, such as make a job offer. In college admissions, data X could be grades and test scores to make a decision as to whether to accept a student. Now, but the decision Y hat can also affect the outcome Y, which is now means that we have to have an arrow between Y hat and Y, which yields the following graph. For example, you cannot default on a loan if you were never approved for the loan. So this graph helps to correct this situation. And this model could be called fairness through unawareness. In this case, the protected attribute A is not used to generate the decision y hat. And the approach leverages conditional independence. That is, the decision y hat is independent of the protected attribute A, conditional on the data X. Now, this stands in contrast to using the protected attribute A in the decision y hat, which may cause overt discrimination within the model. The problem with using the protected attribute A to modify the decision y hat is that it may cause harm to members of less privileged groups. And this harmful bias is represented using the red arrow above. So, and that's, as you can see, that it causes bias within the decision and also bias in the outcome. So we can just get rid of the protected attribute A from the decision y hat, fairness through unawareness. Does that mean we're done? And not quite. Fairness through unawareness assumes that the data X is not biased. While this may satisfy right-wing notions of fairness, it may not satisfy left-wing notions of fairness. As we mentioned before, structural discrimination could cause biases in the data X, which could lead to covert discrimination that can harm less privileged groups, which is shown by red arrows and leverages counterfactuals. That is, we want to be able to compare the outcomes of a less privileged group, the factual, against a more privileged group, the counterfactual, to see if there is a disparity in the outcomes across the groups. So if you've heard of, in fairness machine learning, this idea of demographic or statistical parity, that's basically this test. Now, to correct for covert discrimination, again, left-wing worldview, one might implement fairness through affirmative action. That is, affirmative action is represented by the blue arrow and is a form of intervention. We correct for structural biases in the data by using the protected attribute A in an affirmative way to modify the decision y hat. But if we believe that the data is not biased, again, right-wing worldview, then the same intervention might be interpreted as reverse discrimination that can harm more privileged groups, which is represented by this blue arrow and these blue nodes, which are biased. Fairness is a normative problem, meaning that it has different interpretations based on your worldviews. And this is why bias is so difficult to eliminate in a model, because people can't agree on where the bias is. Now, if we try different variations of these models, then we can find, I found 4 different fairness and discrimination pairs. I think that these are kind of the building blocks for building a fair model. So for example, in this model, we show, let's say, for example, we believe that the data is biased, but biased in the direction where it's favoring less privileged groups. Let's say we believe that the system is biased in favor of, say, Blacks or Jewish people. Then one might perform an intervention in the model to correct for that bias that is giving favoritism, giving preferential treatment to, say, Blacks or Jewish people in order to correct for the bias here in the decision. And this could be called fairness through supremacism. However, alternatively, if we believe that this data is not biased, that it's not biased in favor of less privileged groups, then that same intervention could be interpreted as overt discrimination. As we mentioned before, right-wing notions of fairness rely on fairness through unawareness. The data is not biased, and there's no intervention between the protected attribute A and the decision y hat. But that could be interpreted as covert discrimination if the data is believed to be biased and you don't make any interventions to correct for that bias. If you do make interventions to correct for that bias by modifying the decision y hat using the protected attribute, you have fairness through affirmative action. On the other hand, that could be interpreted as reverse discrimination between the left and the right. Another intervention that you can make is to eliminate the path between X and Y hat. That is, the decision is independent of both the protected attribute A and the data X. And one could call this fairness through lottery because the decision is independent of the protected attribute. There's no way you can use the protected attribute or modify the data X in order to change a decision in your favor, for example. But then alternatively, this could be interpreted as no discrimination. And I put this in quotes because On the one hand, yeah, the model is not discriminating. It's not discriminating on, say, race or gender, because it has no access to protected attribute or any data that could be modified because of that. But also, by definition, so that seems like a good thing, but also, in addition, as a supervised machine learning model, it can't discriminate at all because it has no access to the data. So in another sense, while it's good that it's not discriminating by race or gender, it's bad that it's not discriminating at all because it has no access to any data. And the structure versus agency dilemma leads to this fairness paradox, this idea that fairness itself is one giant paradox. And each form of fairness corresponds to an opposing form of discrimination. And that is, what is considered fair to one group is considered discrimination to the other group. Now let's talk about bridging the socio-technical fairness gap. So now let's focus on this era between the social sciences and humanities and the math and computer science. So as we mentioned before on the social side, we have this causality dilemma where between structure and agency, we can map this to left-wing, more progressive politics versus right-wing libertarian politics. And as we showed before, this actually links to the two fundamental laws of causal inference as defined by Yuta Perl. So Yuta Perl was the inventor of the Bayesian networks that you saw before, the causal Bayesian networks. And he said that basically all of his work on Bayesian networks could be defined by the two fundamental laws. The first fundamental law relies on counterfactuals and interventions. And this seems to square very nicely with left-wing notions of fairness. On the other hand, the other law is conditional independence, which is Yuta Perl's second fundamental law. And this squares very well with right-wing notions of fairness. So, for example, we know that there's that left-wing notions of fairness rely on this idea of fairness to affirmative action, where you're performing an intervention using the protected attribute A, where basically this bias within the data is your counterfactual. So bias is a counterfactual in causal language, and then affirmative action is an intervention. On the other hand, in conditional independence, right-wing notions of fairness, you use the mediating variable W or X to explain away the effect of the protected class A, thus holding everyone to the same empirical standard. So therefore, we can show how left-wing and right-wing notions of fairness can be compatible with the two fundamental laws of causal inference as described by the two preferred forms of fairness to combat racial discrimination or gender discrimination or other forms of discrimination in these models. There seems to be a very nice and simple relationship here. We can also try to map this to the political spectrum. So this is a very high level map, and it may seem to map fairly well, where each of the different types of fairness, lottery, affirmative action, unawareness, supremacism, they seem to line up with different notions, far left, left wing, right wing, far right notions of fairness. In each form, we have different types of fairness criteria. So here's a metric, for example, demographic statistical parity, which is the decision is independent of the protected attribute, subject to some type of intervention, versus right-wing notions of fairness, where your decision is independent of the protected attribute given the data X. In far-left notions, lottery-type notions, the decision Y hat is independent of both the protected attribute and the A and the data X, whereas far-right notions, supremacism, the decision is not independent of the protected attribute. We mentioned before there's different notions of individual and group fairness. So for example, left wing is more focused on group fairness, right wing is more focused on individual fairness. Fairness through lottery, where everyone receives the same type of outcome, can achieve both individual and group fairness requirements at the same time, whereas far right, more supremacist notions of fairness are designed to not achieve individual or group fairness requirements. And then finally, we can map left-wing and right-wing notions to the first and second fundamental laws of causal inference. And I think that these causal links between AI and politics may help policymakers to design better AI regulations, which I know there's a lot of talk among policymakers today. Finally, I'd like to end off by mentioning that it appears that AI systems have different layers of abstraction. So if you think about the main innovation in deep learning is the modeling of hidden layers at the micro level. So there's a lot of talk, for example, around generative AI, which is basically adding attention and transformers to optimize these hidden layers within a neural network, for example. And our main innovation with causal AI is the modeling of causal layers at the macro level. So we showed, for example, you could take a neural network, turn it into a black box, and then put that black box within a node. And now it becomes part of a larger causal Bayesian network. And beyond the scope of our presentation for today, if you take a causal Bayesian network and violate the DAG constraint, so causal Bayesian networks have this idea that it's a directed acyclic graph with no feedback loops. If you violate that and put a feedback loop back into the system so that you can model multiple decisions over time, then it allows us to then jump into the idea of causal loop diagrams. So causal loop diagrams are part of the field of system dynamics. Causal Bayesian networks are part of causal inference, and neural nets are part of machine learning. So there's a nice way of being able to connect these three areas of causality together. So the idea here is that if you zoom into a neural net, you've got hidden layers. On the other hand, when you zoom out of a neural net, you now have these different causal layers to represent the problem. So I think that this is going to help open up a lot of, solve a lot of problems around how do AI systems, for example, impact society? What are the greater impacts of these AI systems? So finally, I think it's my view that we're at the dawn of a causal revolution in AI ethics. So this work was built off of these two giants in causality, Yuta Pearl, the UCLA professor who invented Bayesian networks and received the Turing Award for his work. And then also Jay Forrester's work, which we could talk about in a future presentation. He's an MIT professor that invented system dynamics. And if you would like to learn more, please connect with me on LinkedIn or feel free to email me at this address. We also have a website at epistam.ai. And that's all, folks. Love to hear any questions that you guys might have.
Excellent. Thanks so much, Chris. That was amazing. So as promised, we have now arrived at our Q&A portion of the event. And as I mentioned earlier, we use Easy Retroboard to manage the dialogue with a group of this size. So what I'd like to do now is just sort of talk through and walk through the instructions. When you see the board, you are simply going to click on the plus sign in the relevant column, type in your idea, and when you are finished, hit the blue box with a thin white check mark and save within the field. So your idea is going to appear on the public screen. So if you want to go ahead and go back one more slide, Savannah, and open up the Easy Retro board, that would be great. And we can all take a look at that. Thank you so much. Looks like we've got some questions that are coming in. If you could make that screen just a little bit larger. I definitely had to put on my reading glasses today. Thank you. Super, that is so much better for me. So I am going to go ahead and mute myself, Chris, and if you want to walk through some of these items, it looks like some of the slides here have already been upvoted. So you may want to begin with those that have been upvoted already in the general Q&A portion. Folks, friendly reminder, we'll have about 15 minutes for this. Please feel free to continue to add questions and upvote the comments and items that you would like for Chris to respond to.
So yeah, I see one of them is getting a lot of attention. Can you walk through the causal layers with a tangible example? So credit, etc. Yep, definitely. Let me share my screen again. Oh, I can't share my screen. Oh, okay, now I can. Let me see if I could share my screen. And then let's get back to here. So we have this causal Bayesian network in which what we can do is, as mentioned before, we've got this protected attribute, which is race or gender. We have this mediator W, which represents creditworthiness. And then we have an outcome Y, which could be loan default. And then what we want to do is we want to be able to use this in order to make credit scoring decisions. So we go back here and we show, okay, well, we can measure creditworthiness using data X. So data X is just only a partial measure of one's creditworthiness. If we had perfect information about creditworthiness and the world is deterministic, then we'd be able to perfectly predict an outcome, but we can't do that in reality. So with data X, we could measure, for example, income, credit history, information in your credit report. There is also a question about alternative data, in which I would love to have a conversation with anybody who's interested offline on how to deal with alternative data, because that's really one of the original applications for this research. And what you do is you take the income and credit history to render some type of credit decision, and then you have this type of graph here. So in credit scoring, currently it's being basically fairness through unawareness. So in the United States, you cannot use the protected attribute to modify the decision in any way. And that's because of the fear that this could cause overt discrimination. But this is raises a lot of concerns by people on the left that the data might be biased because it has covert discrimination. So there was, for example, practices in the past, such as redlining, where, for example, Blacks were not able to get access to loans. And as a result, it caused an entire generation of communities of color from being not able to get access to housing equity. And as a result, this led to a bias within the data, which led to a disparity in the outcomes for people who were applying for credit in the future or even in the present. And actually we could, and to model this bias, we'd actually have to go into system dynamics to model the feedback loops to show how past historic redlining practices, which were racially discriminatory because they were causing overt discrimination, created the bias, and that generated the disparities in the outcomes across the groups. So hopefully that helps with understanding the issues around within issues of bias within credit decisions. I know that within credit decisions, there's the issues of disparate treatment and disparate impact. So the point of disparate treatment is to avoid overt discrimination, but then there's this lingering question about disparate impact, okay? And what do you do with disparate impact? Because if you can't use a protected attribute to correct for disparate impact, then that could present potential issues. And I think there's been a lot of discussion within the financial services industry about the issues of what to do with this disparate impact doctrine, legal doctrine. But I'd love to have a conversation with any folks offline because we can dive really deep into this issue. And then let's see what other questions. What other questions were there? Okay. Yes, I have a paper on this topic. So it's a working paper. Let me see if I could share the link. 1 second. Okay, there's a link to a working paper on the subject. Let's see, what else is popular? Could synthetic data help overcome the fairness paradox? How accurate can we get with synthetic data? I haven't really thought too much about synthetic data. Yeah, I'm not sure if I could give a good answer to that at this point. But I think the worry is that will the synthetic data bake in the biases that particularly the left will be worried about in trying to correct for these issues. Let's see, what else? How can you tailor the work you are doing in data ethics to make a larger impact on the field as a whole? I think that, well, I think within using causality to address the fairness problem, it also addresses issues around discrimination, bias, transparency, It also might have issues, or might help with issues around robustness, because these models are robust no matter what political condition you're in. So whether or not the Democrats are in power or Republicans are in power, then or whether or not you need to deal with disparate treatment and or disparate impact requirements, these models are quite flexible, and it also works across a wide variety of domains. So it's a very general model. Let's see, what would you say about the trade-off between fairness versus accuracy? I think that there is that actually with causal AI, for credit scoring, I think that there may not necessarily be a trade-off between fairness and accuracy, especially if you use these newer causal methods. So I'd love to talk to you guys about offline about some of the work that we're doing in causal data science, because I believe that if you use a protected attribute in a credit scoring model, you can actually achieve better fairness and better accuracy within the credit scoring model at the same time. But we'd have to have a more in-depth discussion. And then so it's this idea of a Pareto frontier, and I don't think that we're at the Pareto frontier. Once you're at the Pareto frontier, in which then there is a trade-off, but right now there's no trade-off between fairness and accuracy. We're not at the frontier yet. What were you, when you were talking about credit decisions, you mentioned alternative data. Can you elaborate? Yeah, alternative data is the idea of using information like, for example, where you went to school, where you go to work, your social media data for credit decisioning. And we don't address it within this model, but I'd love to have a conversation with anybody who's in the credit scoring space about how we could use the technology to address accuracy and fairness issues with alternative data. Other questions. What can undergraduates do to better prepare themselves to data ethics as aspiring data scientists? Two books that I recommend for causal inference. One is The Book of Why by Yuta Pearl. So I highly recommend. This is a general book for reading, and then another book that's more technical but a good tutorial, also written by Yuta Pearl, is Causal Inference in Statistics, a primer. So I highly recommend these books for systems for understanding causal inference, because it is my belief that especially as data scientists have to deal with high stakes decisions, those causal inference is going to play a major role. And then for systems thinking, actually there's a site called the Systems Thinker, but in which I highly recommend. But we could probably talk more about that in a future presentation about the dynamics part of this problem, because this is more focused. This presentation for today is more focused on the more static linear parts of causality, not the more dynamic nonlinear parts. Let's see. How can you use ethics and fairness in LLMs to educate users about hallucinations by chatbots? That is, how can users be educated as they use chatbots to not blindly trust their responses? I think at this point, I'm not quite sure how to connect this to LLM. So the focus of this research was more on supervised machine learning problems, so more in classification and regression type problems. Yeah, at this point, I don't have a good answer for how to deal with ethics and fairness issues within LLMs, not at this point, but it's certainly a future research direction. Let's see, what else? Can you review the equation for fairness that accounts for both structure and agency? Well, there's, I guess, what's meant is the models, the fairness criterion. So actually, if I could share my screen, yep. Is it this one? Or is it this one? Oops. I think I'm sharing the wrong screen. 1 second. So were you mentioning the fairness criterion? So these are different types of equations, or the other is the actual mathematical equation, which is defined here for y hat. So the decision is equal to the one function probability of y given x is less to t for some threshold t. So that's this decision function. What other questions were there? Let's see, I'm looking at the board. Is Y prime, I think you mean Y hat. Is Y hat a proxy? No, Y hat is the decision. So this model doesn't show how to deal with proxies. Again, I'd love to have a conversation if you guys are having issues with proxies. So it's related to alternative data, and I'd love to have a conversation offline to discuss how to deal with the proxy issue. Let's see, what other questions? Presuming rules, laws could be defined for AI ethics, how in the world could they be policed? So currently the legal definitions, there's, for example, within credit scoring, there's disparate treatment and disparate impact. So those provide the legal definitions of fairness. So disparate treatment is related to overt discrimination. Disparate impact is related to covert discrimination. So the main challenge is trying to convert these legal definitions into mathematical definitions. And the causal techniques allow you to do that. So as I showed, there are ways to build causal models of overt and covert discrimination. And using that, it provides a pathway to being able to building AI models to meet the legal definitions of discrimination. And if you're dealing with those issues, I'd love to have a conversation with you guys offline, because we do have some patent pending technology on how to deal with disparate treatment and disparate impact using this causal AI technology. What other questions? Can you comment on jurisdictional layering of various AI bills of rights? I'm not sure what you mean by jurisdictional layering, but I do know that within the White House AI Bill of Rights, there's a section on discrimination. So I think that this relates to a lot of issues around the issues that were brought up within the White House AI Bill of Rights on discrimination, such as, for example, in credit scoring issues. It probably could also be applicable to housing discrimination, but I haven't spent too much time thinking too much about the housing aspects of this problem at this point. How do you unify causal effect in humanities and social sciences with the same measures in hard sciences and biological sciences? So I would say, I think that the hard sciences and biological sciences are more focused on using the scientific method to identify cause and effect relationships using an empirical approach. So this is not using the same causal approaches that are used by the scientific method. So this is, on the other hand, which is the scientific method is more empirical. This is probably more rational and intuitive and deductive. So it's using a different approach to causality that's more probably aligned with like philosophical approaches to causality, or a more engineering driven approach to causality as opposed to scientific approaches. So it's more about trying to build models, those causal models. Using knowledge about cause and effect relationships in the world. It's more of a common sense driven approach to causality, as opposed to running randomized experiments using the scientific method. What else? Can you give an example, elaborate on how to use the model for both agency and structure? I'm not sure if we could do it for both agency and structure, but we do have patent pending technology, which we believe will satisfy both disparate treatment and disparate impact. Which is the requirements to meet the requirements of the law. So again, we'd love to have offline conversations to discuss how we do this. It's using a new technique called causal data science. So Yuta Pearl had speculated that such a technique exists, and by being able to show the relationship between causal Bayesian networks and, say, supervised learning models like neural nets, then there's a way to bridge the two techniques, the techniques of causal inference and data science together to meet both the disparate treatment and disparate impact requirements of the law. Although we actually have to test this in the court of law probably to see if this is true. Let's see, as race is a social construct, why should we continue to build systems that try to optimize for decisions that include them? Isn't that inherently continuing to perpetuate bias and not remove it? Again, it depends on the issues of the disparate treatment and disparate impact requirements of the law. So for disparate impact, race is a factor in contributing to disparities in outcomes across race, and racially neutral models could help contribute to those. So that raises issues in terms of complying with disparate impact requirements of the law. And then for disparate treatment, yeah, if you take race out of the model, then you should be able to satisfy the disparate treatment requirements of the law, except when you're dealing with proxies. Again, proxies is it's a more in-depth discussion. Yes, and that's one of the issues. Proxy discrimination. What else? Availability of code. How is what you're doing different from causal forests? I'm not sure what causal forests are. I think what we're doing is more abstractional, maybe. But again, I'm not sure what causal forests are. But it's more just thinking about the different abstract layers of the AI problem. Yeah, I'm sorry, I don't really know what causal forests are. Let's see. To what extent can AI fairness be enshrined into law? Should there be a standard for AI fairness? And if so, what should it be? So I think that, AI fairness is already in some ways enshrined in the law because of the disparate treatment and disparate impact legal doctrines. The challenge is being able to convert those legal doctrines into mathematical models. And I think these causal AI techniques can help do that. How can this causality approach be used to explain outliers? Haven't thought about outliers, so probably I can't give a good answer to that question at this point. Perhaps this is far-fetched, but by dropping in a neural net as a node, can you post-training use this extra node to detect anything about the fairness? Post-training, so there is the part of trying to evaluate the outcomes of the different models. So for example, is it causing disparities in outcomes across groups, so demographic parity issues, or also in terms of understanding how to evaluate the models. So for example, if you're focusing more on disparate treatment, then you're not looking at particular metrics afterwards. So I think I'd have to think about what else to do but post-training besides running evaluations of the different types of fairness metrics that might apply to this problem. Can risk be included in the model? Not quite sure what is meant by risk in the model. So it is ultimately about trying to predict the risk of some type of outcome based off the data. So I think, the whole model is about being able to predict risk. So I kind of feel like it's kind of intrinsic or inherent in this problem. And then, is it possible to separate and or combine personal ethics from with workplace ethics codes? I am not quite sure about the answer to that question. I think there might be issues about personal ethics and workplace ethics that might cross, that might be both valid in this case, but yeah, I haven't thought too much about the personal versus workspace ethics issues.
Chris, you did an amazing job answering all of those questions, and actually, making sure that folks can contact you is such an important part of this event. I have also been having some offline conversations with folks during the end of your presentation who are really interested in following up with you. Folks, I just dropped in the chat. We are eager to lightning question round. Exactly. We are eager to have you reach out to Chris. I just dropped his email in the chat. If you could take a moment to let's see, hop to the next slide and complete our evaluation, that would be very much appreciated. We are eager to hear from you about how we can improve and the topics you would like to hear from in the future. We also have a DataBytes interest form for those of you who would like to propose a topic or subject for presentation, probably later this fall. I think there might be a slot open for, actually I said fall, I think winter, December. So other than that, next slide, please. We are excited to invite you to attend our next DataBytes event in August. That is August 22nd at noon. Kimberly Rabaski from Arrakis Therapeutics will be presenting AI in target identification and drug discovery, transforming the future of medicine. So It's going to be another exciting topic, and we do hope you'll be able to join us. Registration is open for that event, so check out NCDS for more information. Data Matters is our short course series that we produce in conjunction with our friends at the Odum Institute for Research in Social Science. Registration is also open for this short course series that takes place between August 7th through 11th. And with that, it is 4:59. We have an entire minute to give back to you. I am just so delighted that we had Chris with us today. Chris, thank you so much. I would also like to thank my colleague, Chris Calloway at Renzi, for this incredible connection that has just been super exciting for so many people. So thanks again, Chris. This was a great afternoon. Everyone, we do hope to hear from you in the near future. Take a moment to fill out our DataBytes eval for today and reach out to Chris with more questions. Thanks again.
Thanks, Amanda, and thanks everyone for joining.
Bye. Thank you.